Hello. So now we know what a CTF is, we know how to build a team. Now it's time for actually attacking the challenges. So this is going to be a quick introduction about how to discover challenge and analyze the challenge itself. I think that one of the key is to understand what you should do to solve the challenge as quick as possible. So as Laurent says, CTF for fun, cybersecurity amateur. There's a video online that explains everything about this one. About me, I'm just working for Mandian. I'm actually the guy behind the RingZer0 Team CTF for those that know about this website. I'm also a challenge designer for the NorthSec for 3 years now, or 4, I don't even remember. So what we have today, basically we're going to talk about a binary file. We're also going to cover web challenges and challenge analysis. So basically just how to analyze a challenge and trying to understand what's going on just by looking at the value that we have. So again, it's a quick introduction, like binary file. We're just going to cover little tips that can help you figure out which kind of binary you have in front of you, how to solve it without going to the wrong path. So if you have any question during the presentation, feel free to just yell at me and ask your question. That's totally fine with me. No questions so far? Perfect. So binary files. During CTF, as Olivier already mentioned, you're going to have tons of different challenges. So it can be a Linux binary, a Windows binary. It can run on weird architectures such as MIPS, ARM, or I think last year the NorthSec, I did a LES, GB, Game Boy kind of thing. Basically, I just use a build root, compile a standard C program using a weird architecture to make your life a nightmare. And you're also going to have like a standard Intel and architecture. You also have more interesting language such as C, C++, or .NET. Of course, the way that you reverse a .NET binary is totally different than a C program. Because, for example, .NET, you're going to have like the whole MSIL embedded inside of the binary. So if you start reversing it with like IDA, for example, it's going to take forever and you're not even going to see the code that is really interesting. So we're going to try to figure out the best way to reverse a sample by knowing which kind of type it is. So first thing first, just run file on the binary that you received during the competition. It's going to give you a lot of information regarding which kind of architecture it is, which kind of binary it is. In this case, for example, it's a simple Linux binary, nothing really interesting. We know at least that the ELF is the Linux format. You know that this is a 64 bytes. And we also know that it's not stripped. So from a reverse engineering perspective, it's going to be more interesting because you may have a little bit of hint about what's going on inside of the binary itself. So for this kind of binary, usually I'm going to go with GDB, Object Dump, IDA, or Radar2, which is the new kids on the blocks. There are so many other different tools that you can use for reverse engineering. So this is it. Pretty simple, another one. We know that PE32 is a Windows executable. We know that this is a 32-byte application probably. So again, you can go with WinDBG, IDA, Immunity Debugger. The old version is only x86 support, but there's a new fork, I think, that supports 64-byte, which is free compared to IDA or other expensive reverse engineering tools. Next one. This one is pretty much the same at the beginning. It's also a PE32, which is a Windows executable. However, if you look at the end of it, it's a Mono.NET assembly. So this is clearly something that has been compiled using .NET. So this is a totally different approach. In this case, I'm probably going to go with DNSPy or .NET Reflector. They're actually made to reverse MSIL. The cool thing about MSIL, it's interpreted language. So you can pretty much recover the original source code used to build a challenge. Any questions so far? Perfect. So the idea behind this one is we basically going to do a challenge, which is a challenge that I made for the NorthSec a couple of years ago, without even looking at a single line of assembly. The reason is quite simple. We're just going to understand what's going on, and we're just going to discover that there's no need to reverse anything at all. So this is a screenshot from IDA. Basically, IDA is a well-known tool for debugging on Windows. You can also debug Linux program. It supports sort of the architecture if you have the PERT version. So there's one thing that I always look from a binary perspective is the strings inside of the binary. In this case, there's not much to be seen. A couple of information that seems to be related to the compiler. In this case, it's probably GCC that has been used. And there's a little sentence that starts with Microsoft Windows. This is probably some things that we're going to see during the challenge. You have the alphabet. That's pretty much it. There's no int, like for example, there's no password string or username. There's not much going on here. So probably string is not a good option for this one. However, on Windows, you're going to have the import table that contains all the Windows API that are imported by the binary itself, which is also easy to find on IDA. So in this case, if you look at the import that you have for this binary, you're going to see that, for example, there's a lot of API that are related to resources. So for example, you have find resources, you're going to have load resources, size of resources, write file. So usually resources are used to store something inside of your binary. It can be pretty much everything. In this case, we just don't know what it is so far, but we know that at some point probably the executable is going to write something on this because we do have a write file API inside of the import table. Just keep in mind that create file is not writing file on this, it's just retrieve and handle on something. A lot of people at the beginning are going to be confused between create file and write file, but they're totally different. Create file just retrieve and handle, and write file actually writes something somewhere. It can also write something somewhere else, like a socket or other considered a file-based communication channel, but usually it's using for file. So we know that probably this executable have a resource embedded. We just don't know what it is at all. It can be an image, another executable, and it's probably going to write it down on disk. So there's two options, trying to reverse from the write file position and trying to figure out what's where and how it's wrote, or just use another little Windows tool called PropMon. So basically with PropMon, you can just monitor everything that is going on with your binary. You can use that to actually monitor malware and stuff like that. But in this case, we're just going to look for the write file call. And as you can see, when we run the program, it just writes a file in the basically the temp location with a random name.dll. So I'm assuming that this binary is probably just dropping a DLL somewhere on the system. And actually the name is generated randomly every time you run the binary, which doesn't matter because in this case you actually know where the DLL is. So the idea behind DLL is pretty simple. It's just a file that exposes API that can be used and called by other program at some point. So in this case, you just load the newly created DLL inside of IDA again, and you're going to look at the export table instead of the import. So in this case, you have the DLL entry point, which is the default DLL entry point for DLL on Windows, and you have another one called display message. Keep in mind that this is a CTF challenge, so I guess display message is probably something really interesting to call. So the million-dollar question, how do we call a DLL on Windows? Pretty simple. Just use run-DLL32. So basically, you use run-DLL32, you supply the DLL, and you supply the function. And magically, you get the flag. In this case, we don't even know how the flag was stored on the DLL. It was actually encrypted using a little obfuscation routine and everything, so string did not reveal anything. But in this case, just by reversing and understanding what's going on by looking at the import table and the format of the file, we just get the flag without looking at a single line of assembly code. I think it's pretty effective for reverse engineering challenges. And the reason why it works pretty well is because we just figured out what's going on by looking at the import table. We figured out there's nothing really interesting in the strings part of the binary, and we ended up having the flag pretty fast. So that's a perfect example of understanding the challenge, make it way more easier to solve. Any question on this one? So let's move on to the .NET challenges. So as we mentioned earlier, .NET challenges are actually using MSIL, which is a Windows proprietary interpreted language that basically convert C#, VB, and I think other weird language that they created, such as G# or whatever. They have plenty of language nowadays. But basically, it's going to end up creating MSIL that is considered cross-platform on Windows, of course. So first thing first, we just opened the binary on the Inspire. As you can see, this is actually a challenge from the ACFest. I think it's last year. and you're gonna have all the function. The cool thing is you really feel like it's just like C code or C# code. So basically you have all the function, and usually when you have a button click event, this is probably interesting. So probably in this case, the application was just a UI with a text box and a button, so it was waiting for a special key, then it's just gonna check if it's matched something and gonna give you the flag. So in this case, we're just gonna go inside of the button one-click function and see what's going on. So this is the inside of the function. Pretty straightforward. There's a little bit of obfuscation, like if you look at the fourth line, there's like a class with a weird name. So I guess we just don't know what's the purpose of that line. But if we look at the first one, it's called G-Class0 Detect DB. This is just kind of weird, but we may take a look at it. So if we don't met this requirement, we're gonna go probably out and we're not gonna get the flag. The next one is checking if the message inside of the password box is empty. So if it's not empty and still gonna continue, then you have this weird function that seems to take the password as an argument and do something. And if it's true, apparently you're gonna get the flag. So you know that the flag is encrypted using probably 3 DES, and the key is probably calculated from a resource embedded inside of the challenge just based on the name. That's the cool thing about this kind of challenge. If you leave everything as is, you're gonna have a lot of verbose information like that. So you know that there's resources, you know which kind of encryption they use. In this case, the challenge designer decided to obfuscate the important function, which is the WUOY function, to try to hide it. But let's take a first look at the detect deb. So this is the detect deb function. Again, a lot of weird character to make reverse engineering a little bit more painful, but still we don't really care about that value, we just want to understand high 4.0. This is the only 2 things that you need to know to solve pretty much like 90% of the MSIL challenge out there. Basically the IDC.14.0 basically just return false all the time. So we're just going to patch a function using those 2 opcode, and as you can see at the bottom you have the newly created function that simply returns false. So even if you have a debugger, you're just going to be able to go through the challenge, so the debugger check will totally fail and you're going to get the flag. By doing a little bit of reverse on the next part of the challenge, which basically check the number inside of the password field. Okay, anyway. So basically the idea, after you pass the check, the program itself gonna compare a value that it stored in the resources, which was encrypted using some like algorithm. It was I think 3 DES. So basically if you match the value, you're just gonna get the flag. Since you have the encrypted value, you can just calculate the new value because you do have the encrypted value and the key inside of the resources. So you don't have to bother about the debugger or anything at all at that point. So that was the idea. Any question? Sorry for the messed up on the slide. Blame it on Lauren. So for the web now. Basically, most of the time, web vulnerability will be described by the server itself. For example, I usually wrote my challenges in PHP because it's fast and easy. You don't have to basically compile a kernel module to write your code. If you go to other technology like Java, you're probably going to have a different type of challenges because like Java is heavily oriented object language, so you may find a lot of vulnerability regarding serialization of object and other type of vulnerability. So just by looking at the HTTP response, you may get an idea of which kind of challenge you may found. So this is, for example, a screenshot from the RingZer0. So basically, you know that it's powered by a super outdated version of PHP, and the cookie is the default one. Sometimes if you look at the cookie, you may have information regarding the framework that is used because most frameworks are going to set their own cookie. So this is going to provide you a lot of information. So again, just by looking at the site itself and the format of the parameters, you're probably going to get an idea of what's going on. So for example, if we look at the first one, the page equals lorem.php. This is clearly a pattern for a web application that's probably going to include a file at some point. We don't really know at that point what's going to be the purpose of that file, but there's a different type of vulnerability, and in this case, we're probably going to have in mind like local file inclusion or path traversal. So basically, you can probably include some arbitrary file on the system or include arbitrary PHP file that you may control at some point, and it may lead to remote code execution. Just by looking at the URL, you can probably guess that this is not related to SQL injection, for example, because it seems to require a page instead of like a number that's going to be used in a database. If you look at the second one, basically the challenge itself just gives you information about what's going on. So it says it's powered by memcache. So basically memcache is a caching engine used, for example, by PHP to make the server faster. But there's a tons of vulnerability regarding that, like memcache injection. So in this case, the challenge may be related to memcache injection. We don't know, but the challenge may give you an idea. So always read what's inside of the challenge. And remember, there's people trolling, and I'm looking at Lauren at the moment. They were just putting like thousands of space and just give you a hint on the source code. So if you scroll down for an hour, you're just gonna get a little hint at the bottom of the source code. And every year he caught me with this one. So basically just scroll all the time, and you may find hints at the bottom of the pages. Third one, basically this one says token equals and something that seems shady, encrypted, obfuscated, we don't know. There's a little trick on this one. If you look at the end, there's two equal signs. This is classic for base64. So it may be encrypted, and base64 was used to just make it readable, so it's not using any unprintable character or non-printable. The token may be related to a session, we just don't know at that point because we don't have the rest of the challenge. So looking at the inside of the value may hint you on which kind of object is used. So it may be a serialized object, it may be cryptography. So it's probably not like a path traversal or SQL injection again, because the pattern of the application doesn't seem to be related to that. So web, for example, we're just going to take the value from the previous slide, and we're just going to apply the base64 decode on it. As you can see, this is clearly a non-printable character. So it may be related to cryptography because, for example, most of these serialized objects may be printable. That's the whole idea behind the format. And if you look at the X representation of it, you'll see that most of the bytes are pretty random. There's no pattern that are just coming back over and over. So this is it possible to be a SQL injection challenge? Based on what we see, I don't think so. So trying to use like SQL math, for example, on this challenge is probably a waste of time. Is it a crypto challenge? Maybe. Like the value seems pretty random, so at that point, there's a lot of attack that you can try, like padding oracle or just oracle, bit flipping attack, block shuffling. There's another interesting thing about this one, the size of the output. Basically, the size match some block cipher. So for example, if you look at EAS 256, this is 256 bytes block. So if you just make the count, it does match. So it may be possible that this block is actually encrypted using AES 256, or it can be like a RC4, we just don't know. But the size do match the number. It's not an odd number of bytes, so it may be a hint regarding that. Is it a serialized object challenge? We don't know, but so far it doesn't seem to be like a well-known PHP serialized object format, so I guess that's probably not the case. So by seeing this, I think you should just spend time on crypto things, and you're probably gonna end up having a lot of interesting result. So basically, this is just a resume, resume what we just mentioned. So crypto, probably because it do not contain any printable character, there's no pattern. Usually this is probably related to cryptography. The second one is actually a random base64 block, which is actually a PHP serialized object. As you can see, this one is fully printable. This is a well-known format. So just by performing the base64 decode, it may hint you on which kind of challenge. So I guess the second one is probably a serialized object challenge that you can probably control the object or inject some random information into it. And the third one is basically just obfuscation. It's called, most of the time, security through obscurity. So basically this is an application that have a super long base64 block that basically just hides some plain text data. So if you look at the format at the bottom, you have guess, comma, number, comma, another number, comma, false, colon, and something that may seems to be a hash. So by looking at that, which kind of challenge do you think this is? This is probably something related to session management, so the idea is probably to pretend to be someone else than the guess. So I guess playing with the value guess and change it to something like hand-min, for example, may give you some information or advice about what's going on. In this case, it's just going to say that the MD5 doesn't match. So basically, the idea behind the challenge was the MD5 is actually validating the content on the left side of the comma. So basically, you have to make sure that the hash matched the value. So if you change the value, change the hash. And in this case, the hash was calculated without using a secret. So you can just use the value and calculate the hash pretty fast, and you get the flag that way. Any questions? So web again, let's go back to the first one that we discussed. Basically, the size is 58 byte, which match pretty much all of the block ciphers. So it can be AES, for example. It can also be a stream cipher, because stream cipher usually it's 1 per 1. So you're gonna have like your key, which is a stream, and you're gonna have your plain data, which is also a stream. So they're gonna use 1 byte to XOR the other one. So the length doesn't really matter. So it can be both. We just don't know at that point. It's just a question of testing it. As I told you, there's so many different like crypto attacks that you can try. It's just a matter of trying it. But at least you get an idea that this kind of blob is probably crypto related. Web. So for example, if we look at the challenge, the source code was provided to players. So basically, it totally confirmed in this case that the challenge was related to cryptography. Just by looking at the function crypt and decrypt, you know that basically they're doing version dial 256, which is pretty much AES. And if you look at the mode, because each cipher encryption algorithm use a different mode. In this case, they use the OFB mode, which is a different mode. So assuming that we don't know anything about OFB, let's just ask your friend Google. Basically, it's output feedback. It's pretty simple. It makes AES, which is a block cipher, into a synchronous stream cipher. So basically, you just downgraded the strain of AES using this. So if you control the plain text that is encrypted, or you have an output after the encryption, you can probably just calculate the key back by doing a plain text, non-plain text attack on this one by XORing each byte with the key that you just retrieved. So this is the idea behind this challenge. It was pretty much playing with the bytes, and the application was outputting the value that is encrypted. So if you flip the first byte, you're gonna have like gibberish outputted, so you know that you change only 1 byte. And OFB is only applying like the XOR on 1 byte. There's no modification on the other block, which make it a little bit more easier to solve actually. So that was the idea behind this challenge. Any question? Yes?
Every time there is a data which you don't understand, you are applying base 64. If there is a specific reason, you use only that one, you just try some other techniques too.
No, it's just in this case, the base 64 block was pretty obvious to be a base 64 block, and we're gonna cover at the end basically a little training on how to identify what's going on and which kind of value we have. So there's a trick like for base 64 which is pretty easy. For example, by looking at the equal sign at the end of a string. If you have 2 equal signs or 1 equal signs at the end of a printable string like this, you're probably in front of base 64. Just by knowing this, it can save you a lot of time. This is just recognizing which kind of value, and we're gonna cover also the beginning of the base 64 block that also hints you on what's going on in the background. But you can try everything, as Olivier mentioned earlier. Sometimes you're just gonna try to apply all the crypto that you know, or just trying to base 64 decode it, X decode it, XOR with 1 byte, use a different keyboard, type random stuff, and you may end up finding some things. But in this case, you're just gonna adapt your eye and figure out that after doing it, you're just gonna recognize base 64 pretty fast. That's pretty much the idea. Does it answer your question? Perfect. So this is another. This is actually the end part of the challenge. So basically, it's just gonna create a token which is user equals anonymous and a timestamp by default. So the idea was just to forge the admin value instead of the anonymous, and check if the user is admin. You basically get the flag. So the idea was just to create the token that looked like something that we had after. So by doing this, as we mentioned, we can just flip bytes and we're gonna get new value. And the application was outputting the user that you're actually currently logged in. So if you flip like the first byte, for example, of the ciphertext, you're gonna change the U because it's user equal. So by changing this value, you're probably gonna have an error on your application that says invalid token or something like that. So you know that you changed something that is expected by the token. So by moving to the sixth one, you're gonna change the A for whatever by flipping the bytes. So you can just basically write a script that brute force all the key, and you're gonna end up having the admin user at some point. That's pretty much the idea since OFB made AS a stream cipher. Question? Even more crypto. There's a thing that you have to keep in mind. Designing a challenge takes forever. We have spent like hundreds of hours designing only one challenge most of the time. So if we had feature to the challenge, there's probably a reason. We just don't create feature for the pleasure of creating feature. And this is a two years old challenge from the NorthSec. Basically, the application supported two languages, North Korean and English. And I did that for a reason probably. My idea was just not to have this super useful feature. And if you look at the request, as you can see, there's a cookie that is related to the lang. So basically, I guess if you play with this one, it's probably gonna change the behavior of the website by changing the line or doing something else. So again, if you look at the value in the lang, which is FME %3D, %3D is actually the real encoded version of the equal signs. So again, it may seem to be potentially base 64. There's an interesting thing to keep in mind. The size currently do not match a block cipher because it's way too small. So just by looking at that, we probably know that this is a stream cipher even before testing anything, assuming that this is probably encryption. So the idea behind it, we just flip some things as we mentioned for the previous challenge. So instead of an F, we just put a J. So in this case, it just threw an error saying that a require on go fail. So we probably managed to flip the first byte of the encrypted text. So again, in this case, it was just RC4, and the idea behind the challenge was to basically include a file that you control. So the application allow you to upload your CV because I think, yeah, you cannot read it, but it basically says find God in your life, and you can apply for the call by sending your CV. And the CV basically contains PHP code that can be actually included by the patraversal guarantee inside of the lang cookie. So that was the idea. Again, just by looking at the challenge, you have your oracle on the response that basically gives you which kind of letter you have, so you can just forge the path to the file that you uploaded on the server. So it was just combining cryptography, patraversal, and remote code execution. It sounds simple, but actually it's quite hard to achieve because you have to script this kind of attack because it's going to take you forever to figure out the path by just flipping bytes over and over. But just by figuring out that this is a stream cipher, you're going to save a lot of time because you have the output, so you know which kind of character you just generated that way. Any question? No. So this is another example, basically. We just changed the J for H, so as you can see the value changed. We have no idea what's the key. Actually, you can calculate the key since you know the plain text and the encoded value. You can just do a XOR and it's gonna give you the first byte of the key. And you can go that way, but at that point you can also just brute force the whole thing because you have output on each response. So basically just by doing this you can end up having a dot. So you can dot slash to something that you control and you ended up having remote code execution. So we're gonna go to the SQL injection now. First thing, this challenge gives you a lot of int. Admin is not used by default, so it means that in the database there's no admin users. So if you're just trying to imagine what's going to be the SQL query behind this kind of challenge, you're probably going to end up with some things like that. So select the stars from users where username and equals the username and the password equals the username provided by the user. Nothing really fancy, but keep in mind that the user admin do not exist. So let's say, for example, you use the good old admin or 1 equals 1 to make it sure that the statement will be true and bypass the authentication. So basically, admin is false. I totally forget to translate this one. So basically, admin is false, right? Because there's no admin users in the database. Or 1 equals 1 is always true, and password equals empty is false. So basically, it's going to be false, true, false, which actually going to end up not giving you access because the overall result is false. So you're not going to be able to bypass the login. But what about admin or true or 1? Actually, this is just 2-time true statement. So you're going to have false, true, true, false. So basically, the two first condition will be true. Then the second one will also going to be true. So basically, you're going to have like 2 true statements at the end of the day because they're both or, and they're just going to end up being true. So that way you're going to pass through the login. So you can see it that way. If you look at the turn line, let's just have some parentheses behind the whole thing. And basically by adding parentheses, if we just use or 1 equals 1, the first is true and the second is false, right? If we had parentheses on the last one, admin or true is actually true. And instead of having an AND condition, we're going to have an OR condition now because of the fact that we had 2 true statements. So it's going to be, is it true or false? Of course, or it's just going to choose the one that is true in this case. So you're going to be connected. And that was the whole idea behind this challenge, just understanding how SQL works and the magic behind the logic. So pretty much having always true statement is always good. So if you don't know the user and you're leveraging SQL injection, always put through 2 true statement and there's better chance that you're going to pass through it. There's another thing, as you can see on the second example, I only use or 1 instead of or 1 equals 1. And I messed with Lauren a lot of time with that one, but he also messed with me a lot of time. I was the guy behind the submitted the flag is. I probably spent like 8 hours submitting flag is and it never worked. So this is my revenge on him. Basically, I was just creating a little filter for my application that do not accept like equal signs and other considered unsafe character. So most of the online tutorials are far from being complete because people just don't know what they're talking about or they're just writing blogs based on another blog that they read. So playing with MySQL was the best way to actually learn. Just install it locally, run some query, and just figure out how the engine works. For example, you're going to figure out that if you just do or 1, it's going to be considered true. It doesn't have to be like single-coded or stuff like that. There's no point. 1 is considered true by SQL. Same for actually or 2. 2 is actually considered true. Everything that is not 0 is basically true for MySQL except letters. So you can also just do or true or not false because not false is actually true. So this is interesting because you may find some challenges where we implemented fake WAF or WAF that mimic real WAF, and we may block some of the character. For example, it can be the equal sign, the greater than, letter smaller than, or the or and and sign. And just a quick hint, for example, if you face an application that do not allow you to write or and n, you can use the n%, and the pi, and that's actually going to work with MySQL. Any question? Perfect. Challenge analysis. Basically, we're just going to describe a little bit of the challenge that you may found based on the technology used. Actually, this is not always the case, but this is what we usually found. So Java, for example, going to be serialization, super object-oriented, a lot of templating engines. So there's a new kind of vulnerability called server-side template injection. So you may find this kind of challenge on Java-based application, PHP. Simple but full of surprise. There's a lot of bug inside of PHP engine or feature, they call it. Well, basically, some CTF may leverage that to actually come up with a cool idea just by exploiting the way that the framework is working. You're also going to find plenty of frameworks, same for Java. We can just use tons of framework on top of other to just leverage some of weaknesses known on this framework. For example, last year we had the JWT token, which is a standard way to manage session, and we just use the framework on PHP to introduce a vulnerability inside of the JWT framework inside of PHP. Python, object-oriented like Java, totally different approach, like applications are not designed the same. For example, Django for Python is a well-known framework that also used a lot of templating. You're gonna have Flask, for example. So you may find like web application built on top of Python. So the kind of different, the vulnerability will be totally different than PHP again, because Python is using different approach to create a web application. You're gonna also gonna have like C and assembly, low level obfuscation. Usually, I'm probably the only one in the world that I really enjoy writing assembly. And last year I wrote like a purely 100% assembly challenge. I basically wrote it. Took me like way too much time to do it, but I was able to basically use obfuscation at a super low level. There's no way to do that in C, so I was basically using like instruction, misalignment, self-modifying code, a lot of stuff like that to make people life a nightmare during the NorthSec. So basically the kind of challenge that you're going to find on a purely write assembly challenge and a C challenge will be totally different, because on C challenge, you're going to have the compiler that block you from doing some of the cool stuff that you can do at the assembly language. But again, you're just going to approach it slightly differently, knowing that. High-level language like Java, Ruby, trolling the language. There's so many trolls that you can do during CTF. Like for example, the way that regex work on Ruby is kind of weird. Let's put it that way. There were a challenge last year about that during the NorthSec. Basically, regex are broken, let's put it that way, and you had to leverage that. So we're just going to do a little analysis. So let's assume that you're a big CTF team, and we're just going to answer some questions. If you look at the first block of text, what can you tell me about it? Just yell at me.
Separated by these 4 slashes and
Right. So someone says bunch of 0, and someone says bunch of slash. Let's start with bunch of 0. How did you figure it out? Exactly. So it just says that if you have a bunch of capital A on a block of base 64 text, this is clearly just bunch of 0. So knowing that this is bunch of 0, what can you describe about the challenge? Is it cryptography, for example? So basically, this is totally not related to cryptography, and the reason is pretty simple. There's way too much A, so from an entropy perspective, this is probably a super weak cipher, if it's actually a cipher. But as you mentioned, this is probably some things like binary format data, because you have a bunch of 0 that just repeating on the blob of text, which is exactly the answer that I was looking for. So I guess you just win a sticker. And you also win a sticker. Next one. What can you tell me about the next one? Just yell at me again.
Base 64?
Yep, why?
Because of the plus signs. And
Yes.
It looks fairly random.
Fairly random?
There's repetition in there.
Does it mean that it's not random?
I mean, I can't run a primality test from here, but
Say it again?
It doesn't look random, there's too many repetitions of
Yeah.
four letter, 3-letter phrases.
So let's put it that way. Base 64 is used to encode data, right?
Yeah.
But doesn't mean that the entropy of the data behind base 64 is not necessarily as considered crypto safe value. Because keep in mind, we're just going to translate, which is the idea behind base 64. You're just going to change the base to 4, then 6, and you're just going to come out with those values. It doesn't mean that necessarily the plain text is considered not secure from a cryptography perspective, right? It may seem like there's less random because it's base 64, and actually I should have had the plain text version of it, but actually there's probably no crypto behind it because of the pattern itself, as you mentioned. So basically, this is all printable character if you do the base 64 representation of it. And the reason why, as she mentioned earlier, there's no slash, there's a couple of plus, but usually slash are also introduced by non-printable character in your base 64 block. And there's no slash in this one. So probably it's only printable character. And this is really not also binary format because most of it is printable. So let's move to those values. What can you tell me about the first one? Why MD5? Why a hash? So you can calculate the length of a string of value in like less than a second?
Experience, practice.
So if it's the case, I guess you deserve a sticker. So yes, you're actually right about MD5, assuming that you count like him like 32 bytes in less than a second. But there's another thing that we can know about it if we made an educated guess. There's a bunch of non-printable character on this string, right? If you assume that it may be plain text, for example, it's not going to contain any non-printable character. And usually MD5 are just using bytes beyond 00 and FF. So it probably also confirmed that it's probably a hash. If you look at the second one, SHA-1, why? It's longer. What's the size of SHA-1?
20 bytes.
You win a sticker. Let me throw it at you.
Jesus. Yeah, okay. Launch it.
No, the size is right, but this is surely not SHA-1.
Yeah. No, it looks like it. Let's see.
Yeah. So this one is actually only containing printable character, which make a huge difference. And can you give me the length of it, real quick? No, I don't even know the length. But yes, the idea behind this one is printable, all printable character. So it may have been used to just obfuscate something during a web challenge. And this is the whole idea. Like, you probably are super good at challenge because you can just read MD5 on top of your head. But this is what's going to make you more efficient during CTF challenge. If you understand what's going on and which kind of value you have in front of you, you're going to save a lot of precious time trying to figure out what's going on. So have that guy in your team when it's related to X-encoded value. Let's move to the third one. I need the length first. Say it again? Jesus, you're the second one that figured out that. And it's not on purpose. But yeah, basically, what about, except that it's a stack, but give me more.
I don't know what the but it's just the regularity of the addresses and the high frequency.
Right.
Address.
Right. But basically, this is the idea. So he's just saying that this is probably a stack, which is actually the case, but the idea behind it was just to represent just random binary data. Since it's currently not cryptography, again, for the same reason of the a.a. that we found earlier, there's way too much zero, and the pattern seems to be pretty much the same because this is actually memory address. So they're all the same size, and explain why we have a bunch of zeros in it. But again, we know that this is currently at least not cryptography. So it may be like shellcode or something like that that we just put inside of a file. Last year at the NorthSec, we actually had that. I just put shellcode in a text file. So you just had to run the file as shellcode, and that's pretty much it. So by knowing that it may look like addresses, it may be also part of the shellcode, which is not the case. It's just really a stack. So what about these? The first one, what can you tell me about it? Like, what's the backend technology used and what's the purpose of that page, just based on what we see?
ASP.NET.
.NET, I guess a lot of people actually says it's .NET. So what's the purpose of this page? So it lists, that's the whole idea. So it lists let's say the admin profile.
So that's a get file.
Or P for page, for example. That's a get. So
Yeah.
that's a perfect example. It's kind of ambiguous. We just don't know. But it may be something that actually list user or actually include a page. So it may just include the admin page, for example. So this one will require further testing. But the idea when I wrote it was just basically page equals admin. But that's a good point with the profile. So you win a second sticker. Actually, another one. Just because you can read binary. So yeah, but this is a perfect example, as you mentioned. We just need to perform more testing on this one. So if it's a page that actually lists a profile, for example, which kind of vulnerability you may think?
Change the username? Change the username?
Yeah. Okay. So it may be some things that may list other users. Usually when a page is requesting for a user, which kind of backend code is used to get the information regarding the user? Yeah, so it may be a SQL injection if it's actually used to list a user on the database. If it's actually including a page, which kind of vulnerability we're gonna look for? Yeah, so directory traversal or any other vulnerability related to the file system. So that's pretty good. Next one.
ID for delete.
Shopping cart.
Yeah.
So it's probably related to a card for users. So ID is again probably used to query something in a database, right?
Yeah.
Right. And what's the backend technology for this one?
PHP.
Perfect. So this one is pretty straightforward. Let's move to the third one. Who says Joomla?
It's just Struts.
Strut?
It's just Struts, MVC.
Why?
Validator 2.
Is it only used by Strut? Strut, or the right way to pronounce it? Strut. Strut?
Struts 2.
Only Strut use it?
As far as I know, I've seen only this.
I'm pretty sure that pretty much everybody use it on Java-based web technology because it just become a new standard. But you're actually totally right that by default Strut use it a lot. But this is pretty common on Java application when they do an action. So for example, if you submit on a login, you're gonna see like login.do, for example, because this is more like a naming convention. But the idea behind this example was basically just to point out that it's probably Java-based technology, which Strut is also Java-based technology. And what about the parameters?
Session identifier.
Who says serialized object? Why?
I feel like in one of the tools I think that
That's exactly why. So basically, he says that this is probably a Java serialized object just by looking at the beginning of the string. So this is you just develop the I for it. I guess that's the way to say it. Basically, you just know that this is the beginning of a serialized object. And I think I have a screenshot that just show you the beginning, but basically this is the beginning of the Java serialized object. So keep in mind, if you see R0, this is clearly the beginning of a Java serialized object. That's pretty much it. Of course, it's basic C4 encoded too, because Java serialized objects do contain non-printable character. Next one. Encoded session ID? Okay, what about the technology, the backend? There's no extension this time. Maybe, or?
JSON.
Say it again.
JSON.
The encoded object is JSON? JSON? Sorry. Always remove the French accent on everything I says, by the way. It's gonna make your life way more easier. But it's not JSON in this case, it's actually something serialized. It is an object, but which kind of object? You know about the R0 thing, but this one is actually the classic for PHP serialized object. So this is probably the best way to figure out that PHP is probably used. And as you mentioned, it may use an MVC model because there's no extension, or also some things like mod rewrite on PHP, for example. So you can just rewrite URL. Again, we may have to perform a little bit more testing because we just don't know at that point, but the TZO actually told you a lot about the object format. So let's move to reverse engineering now. What can you tell me about the first one? let's start with actually.
Assembly language.
Oh, oops. Assembly language.
Yeah.
You win a sticker.
I'll come get it.
Tell me more about it now.
Okay, we're pushing something into a register. I don't know what you do next week anymore. And then we're calling a subroutine and then we're moving things from one register to another. Sorry? Non-copy? Okay.
Okay. So,
What's LEA? I don't know.
me neither.
Sorry? Right. And then we're moving some more shit. And that's the length.
Yeah, that's pretty much the idea, but let's move to an easier question or more complex one. Actually, is it Linux or Windows code?
Linux.
Who says Linux? Why?
Because of the underscore in front of everything.
You sure?
Underscore printf.
Report error prop from here.
Someone says something.
The a-toy function?
Say it again.
The a-toy function?
HY.
Yeah, a-toy. Is that
H1.
Yeah, no.
I'm
HY.
probably blind, I just don't see.
Referring to
Ah, yeah, the report error. Okay, gotcha. But
I think it's Windows,
it's Windows, why?
because of the C declare.
That's a good point. Well, let's just go.
C-decal. Oh, Christ.
Let's go back with Linux because it's quite interesting, and this one is kind of a troll. You're partially right. Why?
Is it whining at us?
Actually, let's talk about the compiler used. Which compiler has been used for this one? Oh, I heard GCC. That's probably why you have a bunch of underscore at the beginning of the function, because it's actually GCC. So, as people mentioned, this is actually Windows-based, and this CDEC is a big int, and the fact that it's probably using GCC is probably the answer. So, also, you know for sure that this is a function. It's not just purely write in assembly because of the push EBX and sub ESP which is basically the way that the function will assemble a piece of assembly because there's no like RAX and stuff like that. So that was it. And underscore EMP underscore is classic for GCC under Windows. So let's just not sure what's the order. Okay. Let's move to the one at the bottom. What you can tell me about it?
We're at the bottom. Top R12.
ARM? Why? I think ARM is using the concept of branch, isn't it? So the jump at the end, does it look like a branch? Just asking.
Jump to non-zero?
Jump to not zero or whatever. The location is not really important, but the question is it a compile function or something that has been purely written by a human? Exactly. So this guy says it probably has been written by a human. There's no prologue on the function, and this is actually the case, and this is part of the challenge that I wrote. So is it 32 or 64 byte? Bits or whatever someone's called. Yeah, I always mess up with bits and byte. 32? R12 is supported on 32 bits. I think it's a register that can only be used on 64-bit system. You're actually right about the fact that we're moving bytes in Word, which is actually smaller enough to be on 32-bit system, but Pop R12 actually leave the fact that this is 64 bytes, and it's purely right in assembly. And just by looking at that, we don't know if it's Windows or Linux, because it's just purely, it's just assembly without function declaration and stuff like that. And in this case, it was actually Linux. And it's actually self-modifying code. So basically, I'm patching the code by just changing the value inside of it. What about the right side of the screen? What can you tell me about it? Say it louder.
C code?
Yes.
Yeah.
OS.
Linux.
Why? Just based on the name? If you look at the segment name, can you tell me something about it? Is PLT and GOT is something related to Linux by any chance? Yes. So basically GOT table and PLT table are used by Linux. Also, nothing seems to be related to Windows API, and as someone mentioned earlier, the underscore before the function name, in this case there's only one, which is typical for a Linux function. So that's pretty much the idea. Now you just have basically the answer for all of them. And I think this is the last part of this quick introduction to challenges. Basically, don't run scans during CTF. It's not going to help you. Basically, you're just going to jam the network. It's not going to give you any flags. So just use your head. And since you just learned a little bit about how to identify challenge in the future, I hope it's just going to help you to be more efficient at identifying which kind of challenge you're facing. And as Laura introduced you, if you have the right guy for the challenge, just tell him, hey, I found something that looks like a crypto challenge. So you're the crypto guy. Can you just jump on it and fix it? And you'll be solve it, not fix it. Sorry. And basically, you may found flags faster than you thought just by figuring out what's going on the challenge. So that's it for me. If you want to practice before the NorthSec, hope you're gonna attend. You can go on the RingZer0 Team or just go on Twitter. So at that point, I'm just gonna pass the mic to François.
This is all the challenge.